This lecture video is to introduce you to the concept of migration, which is something that we do to reflection seismic data in order to make the data be a closer representation to the subsurface. By the end of this video, you should have a conceptual understanding of migration, be able to describe what it is, why we do it, and a little bit about how we do it. You will not actually be migrating data by hand. So here is an example of a geology that we could attempt to image. So each of the different colored segments here is a layer underground that's just resting at a different angle. We can send energy into the ground and it's going to reflect off of these boundaries, and some of those reflections are going to make it back up to our receivers at the surface. When we examine the data that results, the reflections from these layers appear as if each reflection is plotted directly beneath the X position of that geophone, even though the reflection actually comes from the side. If you look again, you can see here that the reflected energy is actually coming from the side, goes down, bounces back. But when we plot it, it's going to just be plotted under that geophone. And so if you were to just look at it, it looks like there's a reflection right here underneath when actually that little squiggle line came from over there. So if this is what our data looks like, if we were to interpret the reflections, right, all the little squiggles, as actual layers under the ground, we might think that the locations of the subsurface layers are where we see the reflections. And we might try to draw in the boundaries of those layers on our graph like this and think that those are actually the locations of our layers, but of course this isn't the case. For one thing, it looks as if these layers overlap with one another, and that's just not even geologically feasible. Here I've superimposed the true geology and the apparent geology on the same plot, and you can see that there is a pretty big difference. So how do we figure out where the reflected energy actually comes from and make our seismic section look like an image of the true subsurface, of the true geology? Well, we start with what we know. We know the velocity of the first layer, presumably, because we've already figured that out. We also know the two-way travel time. This is what we measure. From these pieces of information, we can place the true location of that reflection somewhere on a circle centered on the geophone. This is exactly like we use to figure out where on Earth an earthquake occurred by looking at the travel time distances from different seismograms. Well, we can do the exact same thing with our XT data. We know that that energy came from somewhere along this circle. We just have to figure out where. If we keep doing this for every geophone and we keep drawing these half circles, some of them are going to overlap constructively, and this will outline the lower, where the energy actually belongs in the subsurface. Like this. So this is actually the true location of the reflector, which is found by saying, okay, we know the reflector is somewhere along this arc and somewhere along that arc and somewhere along the next arc, and where all of those energy bands add up constructively, that's the true location of the layer. Doing this and recognizing that the energy actually belongs off to the side in this true location where you have all of this constructive interference, that process is what is called migration. You can repeat this process to determine the location of the next segment and the next segment, and so on. Ultimately building up a more accurate representation of the subsurface. So just again, migration takes the energy that we have, repositions it where it actually belongs by recognizing that that energy occurs somewhere along a half circle and figuring out where the energy on each of those half circles interacts with the other energy constructively from the different geophones. They used to do this by hand, but today we have computers that perform migration for us. And that's it. Migration is this tool that we use to recognize that the energy we record does not all necessarily come from directly beneath our geophones, and instead it often comes from off to the side, and migration is the process which can locate the true location of that energy. So if you look at an unmigrated section and compare it to a migrated section, an unmigrated section is going to have all the energy appearing directly beneath the geophones, and a migrated section is going to have the energy appearing off to the side if it should appear off to the side. So a migrated section corrects the energy to be representative of the true geology. That concludes this lecture video. Hopefully you have a little bit better of an understanding of what migration is, why we do it, and how it works.